Wow, imagine not making a YouTube video for, I don't know, 2 years and then just completely disappearing off the face of the earth. Huzzah! Guess who's back? Yeah, well, it's not only Andy does calculus anymore. It's Andy explains tech because I got a website. I thought I wanted to explain tech, but yeah, as it turns out, I still have a thing for math. So here we are, ordinary differential equations. And yeah, I kind of got bored in 2019 of just regular calculus. Because I just took Calc 2 and I didn't really want to regurgitate it because it was a pretty rough course, despite doing well in it. And Calc 3, I don't know. Hey, they might come later. I don't know. But really, I just want to do ODEs because they're interesting. And so, yeah, I'm going to, make a little series here. Like, okay, how do you do ODEs? And, well, I guess first off, why don't we define what they are? Ordinary Ordinary differential equations are equations defined using their derivative. So, like, it could be something like, y prime equals 3y plus 2. Like, that's an ODE. You're defining it using the derivative right there. And, there are methods to solve it. So I've got a simple example here, and it's a guiding example. So we have this equation right here, x prime equals x. So what this means is, the change it's implicitly defined. So the change in x with respect to t equals x. So basically the derivative of x with respect to, some variable t is itself. So what this means is it's actually an exponential function because that's the only thing that can really do this. I mean, okay, let me just separate that out so it doesn't look like crap. But yeah, basically you derive the exponent. X prime is still going to be e to the t. Well, actually, k e to the t because, the constant is going to remain there. So basically, any constant times e to the t, and you're just going to keep getting it back. So that's a very simple ordinary differential equation, and that pops up everywhere. So e to the t is very important to this course. Most of the expressions are going to actually have e's in them because that nice little property, their derivative is themselves. So I've got another simple example here. We've got x double prime, so the double derivative of x plus x equals 0. And this might seem a little difficult, but like when you think about it, there are only like two functions here that will actually work. Well, there are probably more. I'm just stupid, so yeah, only two. And they're sine and cosine, so I'm just going to write them out. Sine of t and cosine of t. And I'm going to, yeah. Those are the two solutions here because x prime of sine equals cosine. Derive that, you get x double prime, and you get negative sine of t. Negative sine of t plus sine of t is always going to be 0. Now, same with cosine. You got x prime equals negative sine of t, and x double prime equals negative cosine of t. Once again, add them up, always going to be 0. So these are all great, but like things get a little bit difficult when we examine the first solving method that you learned in ODEs, which is called it's called separable equations. So what we got here is y prime equals 4x to the third times y. And what we do here, well, let's recognize that, this is derivative of y with, derivative of y with respect to x here. So dy dx equals 4x to the third y. Wow, that's a crappy 3. But anyways, like what we can do here is we can actually put the y over here with dy, and we can multiply everything by dx and get dx over here. So what happens is we get y dy, well actually 1 over y dy, my bad. So dy over, well, why don't I just make that a little less confusing for you. 1 over y dy equals 4x to the third dx. And what we can do here is to solve this, is we integrate. And what happens here? Well, we get ln of y, natural log of y, equals 4x to the fourth over 4, so just x to the 4, plus some constant. And that's great, but we don't really want to be dealing with ln of y. We want to, simplify that. So we're going to exponentiate everything, and we get y equals e x to the fourth plus c. Wow, that is bad handwriting. Okay, but we can also rewrite this as y equals k e x to the fourth. And what the k is, it comes from this. Like, basically, you take this, the exponent right there. You can write this, by the rules of exponents as e x to the fourth times e to the c. Anyways. But yeah, this becomes k. You stick it down there, and y equals k x to the fourth. So these are called separable equations. And we got another example here. Y prime equals e to the negative y times x minus 2. And what we do here is we just, divide this by e negative y, and what that does is, by rules of math, yeah, very, very specific, aren't I? dy dx, okay. And what that's going to do is it just become e to the y over there equals x minus 2. And now we're going to integrate, well, actually, multiply everything by dx, and then integrate. So e to the y dy equals x minus 2 dx, integrate, and we get e to the y equals x minus 2, or x squared over 2 minus 2x. And yeah, plus c. Wow, I'm forgetting everything. Okay, and then, to actually get that back into y, we just natural log everything. Y equals ln x squared over 2 minus 2x plus c. And that's what you get there. So this is great, but a lot of people have problems with constants. So how do we get rid of the c? Well, there's only really one way to do that, and you need something called an initial condition. So it looks like I forgot to erase the work there, but I'll guide you through it. So basically what we do here is we solve the ODE, and then we figure out c by just, plugging it in. So we're given this problem right here. Y prime equals 3x squared plus 4x minus 4 over 2y minus 4. And we're given that y when x equals 1 is going to be 3, because this is y of x. I should probably have noted before that these are functions, typically. So well, y is a function, x is going to be a number. But yeah, basically what we do here is I'm going to guide you through it because I'm lazy. You just sort of move everything over. We took that 2y minus 4, multiplied it over on the other side of the equation. We converted y prime into dy dx, and then we just moved the dx over. We integrated. We get this right here, y squared minus 4y equals x to the third plus 2x squared minus 4x plus c. And now we just take that 3, plug it in for y, and we take that 1, and we plug it in for x, and we get negative 3 equals negative 1 plus c, and so we get that c equals negative 2. And then this is not actually the full process here. I abridged it because I want this to be a short little video. You just stick it in there, and you get this result right here. Y squared minus 4y minus x cubed plus 2x squared minus 4x minus 2 equals 0. And what you would do here, I got this example from Paul's Online Math Notes, he's a god, you gotta check him out. But basically what you would do here is you would solve it using the quadratic formula, and you get 2 solutions of y. But we're not going to do that. You can just go check out his website and do that, or you could do it on your own. But we're in higher level math. You can figure that out. And so I got some key takeaways for this lecture. So all these equations are separable first order equations, which means they're only defined using the first derivative, except for that, sine and cosine one. They're pretty easy. You just try to get the different variables on either side, and then you integrate, and then you do what you need to do to get an explicit y solution. e to the t, or, e to the x, and trigonometry pop up quite a lot. There's a lot of natural logging going on, exponentiation going on, and initial value problems allow you to find the missing constant when you do integration. And that's all I have for you today. Sorry for the long absence. But yeah, I guess I'm back and I'm going to make this series. So yeah.